Good afternoon, everybody. Martin Rapos, CIO of Flexnode. So I have a quick presentation, and it's mostly pictures, which is slightly different from the previous presentations, which were extremely informative. I loved the concept, I have a slightly different approach. So Flexnode is a data center developer. We build data centers like airplanes, very different from the hyperscale data centers that you may have seen. And we do that for one reason, which is, well, there are several reasons, I guess, but one major reason is the problem in the electricity network. The data center industry has really evolved tremendously in the past 2 years, more than in the 30 years before. As you know, mainly due to AI. Now, AI is much more power dense, and therefore the racks are at 130 or so kilowatts per rack, whereas it used to be at about 5, 10, 15 in the past 20 years, and it evolved sort of linearly, and now it's ramping up. So the way that electricity network is set up is fully centralized, despite a lot of renewables that are being ingested into the grid, and there are some concepts and projects on microgrids and decentralized generation, but it's not really a mainstream yet, right? So the grid, the power generation and the power transmission and distribution hasn't changed for about 100 years now, 120 years. And we have data centers which are sort of copying that concept, because they are connected right to big transmission lines, and they are built in bulk. And the economy of scale that help you to improve efficiency on getting the data center built up is really hiding the inherent inefficiency of the air cooling that has been the way of really providing the cooling for the computers, right? So because it makes sense to do it at a scale, you are basically covering for the inefficiency of the technology. Now with AI, that has to change. So what we're doing, we're basically building on the distribution grid and lower. We're going where the power is available. That is because I live in Northern Virginia, where it's the data center alley, the hub of the internet, where more than half of the internet goes through. Huge data centers, hundreds of megawatts of data centers, and huge transmission lines. However, they got out of capacity, and now you have to wait 7 years to get a approval for a connection if you want to build one of these large data centers. What is possible, though, anywhere in the world, is to go lower in the grid, from the transmission to the distribution, mid voltage and lower. And you can build either directly at the substation, which we're doing a lot, working with several large utilities, or even below the substation in the distribution grid. If you are able to leverage stranded capacity either in buildings or greenfield, and you are able to work with the constraints of the capacity. So, and this is what Flexnode does. And let's talk a little bit about how we leverage open source to create data centers like airplanes. Therefore, how do we actually leverage 3D digital first to build a data center that can go anywhere, that is liquid cooled, and is powerful enough to host AI racks, including currently what we're working on is GB200 and NVL72. So the latest, and of course next year there are other architectures that we're already working on. So we configure everything in 3D. We use Netlify and Babylon.js framework to basically create a 3D library to cater to the configuration requirements of our clients. And we build the system in a virtual space first. We build the IT rack system, so that's the data room, which is basically this one. And then we build all the adjacent infrastructure distribution, switchgear, UPSs, which is where we really can participate. If you think about it, if we're deployed on a substation, we can really participate in balancing and grid management ancillary services. We just had a great conversation on that. earlier on. So that is our initial configuration, and this is how it then looks like, and we go into simulation. So we use open source formats to take the outputs of that configuration, and we run it on computers for physics-based modeling, basically computational fluid dynamics. So what that means is we take and convert GLB models, which are basically libraries of the 3D objects that we configured, and we bring that into, we convert it to USD and run it on NVIDIA Omniverse right now, but of course, there will be other alternatives. So we spruce off for that CFD, computational fluid dynamics, to see how the data center will perform, temperature-wise, pressure-wise, airflow-wise, and so on. The thing that we are currently working on is how do you actually ingest line diagrams, schematic drawings, and other architectural materials that we get from different trades as we are putting this configuration together, right? Because you share in building information modeling. We basically blend industrial design with building design, and we share building information models with our suppliers. We go out and we source all the parts. So one data center that you've just seen, that was the 1 megawatt that I was showing before, comprises of 30,000 parts. And we basically build it together like a Lego. And then we deploy different types of AI reference architectures based on what our clients need. So what we're looking for is really a way for managing, and we're building algorithms for ingesting and integrating line diagrams and BIM models into this 3D workflow, that after the simulation, really, it's just a back and forth, a standard building process. Architects, engineers, back and forth on the BIM models to get it done, build it on, bring it on a site, and pre-assembled components, bring it to the site and deploy and hand over. So this is just a sneak peek into our kitchen on how this essentially becomes an industrial building system. So what I really want to talk about though today is operations, because when we hand over the data center into operations, because we have all that information about how it was built, we have an information about every single part that goes into the data center. We know where it came from, who installed it, when, and how it's supposed to perform. And then we want to check that it actually performs as we were intending. So what we've done is we are developing a digital twin tool larger than open source components, leveraging RxDB, where we are ingesting information from the field, from telemetry in the data centers, which we basically connect via MQTT through an InfluxDB time series database, which we then connect to different SCADA systems, data center management systems, fire suppression systems, security systems, camera systems with image recognition and patterns and alerting systems, all of the good stuff that we need to securely manage this infrastructure. So that concludes my presentation. Thank you very much. I wanted to keep it really short because it's right before the lunch, and I wanted to keep it very interactive in terms of having the pictures to show you. If you have 1 more minute or so, I can show you an actual live system if I connect my iPad to this monitor, just to show you how we can actually configure a system like this and how to bring in live data. Is that okay? Yeah. Okay, cool. Oh, and by the way, big thank you for LFH to have us on the board of the foundation. It was an honor to serve on the board, and it's a great experience knowing you all. I also would like to thank our partners that have been helping us to build this. So these are all large engineering firms and construction firms from around the world that have been for the past 5 years really helping us hammer out this concept. They are all obviously building data centers. While I'm connecting the iPad, another couple of things we're looking at. So we've implemented Anilog, which is Edge Lake software for an alternative to the InfluxDB, monitoring. We basically look at working with Open Horizon as well, Open Nebula. So we started discussions there because it makes just too much sense to your presentation point, on a distributed level. If you think about having hundreds of these, and thousands of these eventually, to manage it in a lean fashion. So this is the configurator. This is the Netlify Babylon JS. What you see here is so much more than meets the eye, because this really starts the database of all the objects, right? So all the racks, the cooling systems, going into the detail, the meet me rooms, all the elements. And this is an air-cooled system just to show you how big this is. This is a 300 kilowatt data center. Now, if I go back and I choose a liquid cooled, let's say single phase rear door, I can get a 1 megawatt system, which then is assembled from these parts that we bring. So this is the 30,000 parts that I was talking about. Remember, this is how you bring it on site, assemble it, and you bring in the integrated racks. Now, this is a 3 times bigger system in a smaller form factor, liquid cooled, this is, I think, we chose a rear door. So this is featuring Motive Air rear door. Basically, if you look at how the system works, and by the way, the power density is 1300 watts per square foot. Before we had like 200, right? So this is 5-6 times more efficient and more dense. Now, when you look at how the cooling works, we take most of the heat away by this spine, which is called a manifold, that pulls warm water essentially out from the chips. So it's direct to chip cooling, where you basically cool the chip directly through a jet or through a flow. You pull the water out. That's the red, and that's the red pipe, and then the blue pipe is pushing cold water in. The Motive Air is basically pushing air from the back of the rack into the front, where it's air conditioned, and that's just for the remainder 15% of cooling that needs to be rejected from the data center. So, as I said, this is really just a configurator, but it's also a start of a process, of a digital twin process. From here, we do all the back and forth with the engineers and the simulation and stuff. So I just fast forward to where we end up. So this is then our digital twin system, where we can look at the particular. So this is a deployment we have in New York. If you're in New York and Long Island City, we have our showroom there. Please let me know, and I'd be happy to host you. So if I click on the sensor here, I can just add a sensor that I have there to read, and you just see it's a point and click, goes to our RFDB, and it's a live MQTT data. As you see, 1240 temperature, pressure, etc. You can do historical data, set up thresholds, all that kind of stuff. You also have cameras connected to this, and so on. And so without further ado, I'll just show you the coolest feature we have here. And I'll end with that, and that's basically an AR walkthrough. So I just changed to an AR view, and you can literally, I'm holding the camera, and you can literally just walk through the data center in here. Right, so let me just I lost it somewhere. Sorry for that. Okay. And as you can see, we've got tons of 3D models from different deployments, and I clicked on something. I'm sorry. I think it's lunchtime, right? It's the iPad is hungry. Okay, so that was my presentation. Thank you very much. Please feel free to reach out. My name is Martin, and happy to talk, especially on how we can leverage open source software to help us build that platform, and how I can help you maybe leveraging a similar process on the edge to build other stuff. And of course, if you need a data center, let us know. We know some people that can make it happen for you. Thank you.